Hello and welcome to Code with Star. I'm Star. How are you doing? Today, I want to talk about disposable in .NET. It is a very important concept. Doing it wrong could lead to memory leak, database connection pool starvation, unexpected file truncation, etc. etc. Those bugs are usually nasty, so we want to avoid them. I plan to start with basic concepts. Then I'm going to show you an example when Dispose is not properly called. We're going to look into how to implement IDisposable and a little bit design consideration for inheritance. Let's get started. You're watching this channel, chances are, you already understand. C# code is managed code. The code runs on top of a runtime. The runtime manages a lot of resources for us. For example, the most famous memory management mechanism, garbage collection. Thanks to that, we don't need to worry about memory allocation or deallocation for objects any further. Those resources are called managed resources. But there are another set of resources that is not managed by the runtime. For example, file handles or database connections and so on. Those are called unmanaged resources. We, as developers, we're responsible for writing code to properly deallocate the resource after finishing using them. And that cleanup procedure is called Dispose. How do we do that? Call Dispose method on every single IDisposable. Let's take a look at an example. Let's start with an empty console application and say we're going to output something to a file. Step 1 is to open a file for writing, and let's call it output.txt. Now we could write the stream directly. It makes writing string easier if we have a stream writer. So I'm going to create one here. And let's output something. Now we want to call Dispose method on IDisposable, right? But what is IDisposable? More precisely, which class implements IDisposable here? Let's find it out together. When we go to the definition of the stream class, we see it implements IDisposable. So stream needs dispose. Let's go to definition of file class. It's a static class. It doesn't implement any interface, so file doesn't need to be disposed. Let's check the stream writer. Stream writer derives text writer and no other interface. Does that mean stream writer needs no dispose? Not yet. We need to follow up the hierarchy. So let's go to the definition of the text writer. Oh, text writer implements IDisposable. That means all its derived classes need dispose too. So remember, any class or its parents that implements IDisposable needs dispose. Okay, once recognized, to dispose them is simple. Just call Dispose method on the objects after use. Now the writer will be closed on line 4. The buffer will be flushed. So does the output stream on line 5. Case closed. Well, except the real code is going to be way more complex than this. And that means a lot of things, and one of them is exception. Let me throw one to make the point. And as you can see, in this simple case, even the editor knows that Dispose is not going to run. So how can we overcome that? Follow me to update the code. We put in those logic into try finally, so that even if there's the exception, those Dispose methods are still going to be executed. And that is the core for this video. Find the objects that needs dispose and dispose them. Remember, the runtime handles the managed resource, and it is very important for us to handle the unmanaged. It is so important. There's a keyword in C# to replace this try finally, and it will call the dispose method for you. The keyword is using, and here's how to use it. When you wrap an object with the using, it is equivalent to the previous try finally code, and it calls the dispose method automatically when quitting the scope. Here I leave the try finally on the bottom of the file, so you have an idea how is it simplified. Actually, this can go even simpler when you having two using stacking up. I just realized we haven't run the code in a single time. Let's do it quickly, and we move on to another topic. Well, you see, the exception is thrown, but we still get the complete file. Worth the effort. At this rate, have you ever wondered what could the real damage be? Next, I'm going to show you that. Let's start by changing the code back. And let me delete the output file too. And if I run the code now, you will immediately see the problem. Although the output file will be created, there's no content. That doesn't agree with line 9, right? The problem is, the string of hello will be there in the buffer, and the buffer never got a chance to be flushed. Well, you might be thinking, the bug is not that nasty. After all, if you run a test, you're going to spot the empty file. Okay, firstly, I wouldn't rely on that. Secondly, let me update the code a little bit. You probably don't need my explanation of what's going on, but anyway, I'm going to write 850 lines of output. Each line will be the line number of its own. Of course, since I am a developer, it starts with 0, and the last one would be 849. Well, let's run the code and see. Check the result, start with 0, end with 840. I thought we agreed on 849. Now you see how nasty this could be. There are some results. The file isn't empty, but it's truncated unexpectedly. So, tie the loose end, don't let this happen to you. Well, if you trust me, the real code is usually way more difficult to debug, and the result could be more damage. Thinking about incomplete XML or JSON, and don't ask me how do I learn it. Let's fix the code. And let's run it. Let's check the end of the file. 849. Just like I mentioned earlier, there might be other issues like memory leak or database connection starvation. They are important, they are real. This video is not going to help you catch all these nasty bugs, but I still hope this could provide some leads, some best practices. Coming next is a slightly advanced scenario, and we're going to talk about implementing IDisposable in the class. Let's take a look. When dealing with disposable objects, there's a rule of thumb: who creates, who disposes. In our previous example, we created the stream and the stream writer, and we dispose them right after use. The scope of the IDisposable objects are within the methods. From time to time, we run into the situations to hold those IDisposable objects a little bit longer. Let's take a look at this example. Here I'm creating a dedicated text writer of my own. It takes in the file name in the constructor. And it supports to write a message to the target file. The file will be dedicated to the application, so I want to open it when my text writer is created, and I'm going to establish the stream in the constructor. At the same time, also considering we're going to use the stream writer in the method, I'm going to make the stream and the stream writer fields. Now you probably are a step ahead thinking about how to dispose the stream and the stream writer, because we know those are disposable. Stay with me a little bit longer to just wire the function up. It's as simple as call writeLine on the stream writer. Now imagine the execution flow. The client creates my text writer and call this write message, which in turn calls writeLine on stream writer. And we all know at this moment, the message will be put onto the buffer. And then what needs to happen? When the client's done, it needs to tell my text writer, hey, I'm done with you. Go ahead and clean up the resource. And does that sound familiar? Yes, of course, it's IDisposable, right? So if your class is creating disposable objects and they are held on as fields, it has to implement IDisposable as well. Now there's good news and there's bad news. The good news is IDisposable interface is very simple. You just need to implement one method. The bad news is it's not easy to implement it correct. Let's focus on the bright side now. We have two pieces of unmatched resources here in this class. Let's dispose them. You would usually dispose the resource in the reverse order of creation. You would want to assign the object to null as well, so that the GC will handle the managed part. It's out of scope, but you need to know at this moment that dispose could be called several times from different threads, and it is common for people to throw in a boolean to handle that case. And you also need to pay attention to the case where stream writer becomes null in a multi-thread environment. When write message is called, it will be your decision to ignore it or throw an object disposed exception. I am taking an easier way here, but I also understand this is a trade-off, for that piece of message would be gone. Is this tedious? Yes. But we understand this is important to do. Now, let's take a look at how my text writer is actually used. Coming back to program.cs, and let me comment out the existing code. Let's start with the using statement, because we know my text writer implements IDisposable. This time, output2.text. Then I'm going to call the method writeMessage twice. As long as the writer is not disposed, we know the stream is always there, the stream writer is always there, until it hits line 24. That is when the dispose method on my text writer is called, and all those unmanaged resources get released. The only thing that I want to call out here is that program is not responsible for disposing stream or stream writer. That is the implementation details of my text writer. So again, who creates, who disposes. Let's run and see. Let's check out what's in output 2. Hello world, no truncation. That is great. Are you ready for take one more step up? In the words, inheritance. I am kind of old school. I don't encourage people to seal a class. But if you implement IDisposable like what I did, you should seal your class. It is because based on the current implementation, there's no way for the derived class to override dispose method. That makes the child class very difficult to dispose their own resources. But what if I do need the class to be inherited? I'm going to give you a pattern, as well as some of my understanding of the considerations. First, we need to unseal the class, of course. The next thing is to give the derived class something to override. We could make the dispose method virtual, but we want the derived class to only focus on disposing its own resources, and not too complex the situation with the disposed or anything like that. So a more common way is to introduce a disposing method, and we move all the calls to dispose method there. And of course, don't forget to rewire up everything. Okay, that's pretty much it for the parent class. Let's see how to extend it. I am going to create my text writer v2. There are two things to notice. Firstly, my text writer v2 doesn't implement IDisposable directly any further. This is just like the stream writer doesn't implement IDisposable as well. It is the text writer, its parent, that implements it. 2. This class can override disposing method when and if there's anything it holds to dispose. And you probably noticed, this disposing is simpler than the dispose method. This is intended. We want the parent to handle the complexity as much as possible, but allow the derived to dispose its own resources. Of course, in this case, we don't have any here, but I think you get the point. Now, only to make it a demo, let me update the code a little bit to output it to a different file. I'm calling path.change extension, so that the extension would be v2.text, and then update the client code to use my text writer v2, of course. Now let's run it. Well, newer version, derived class, still no truncation. That's it for today. Please allow me to repeat myself. To dispose unmanaged resources is important. I hope you enjoy the content. As always, keep coding, keep improving. And I'll see you in the next one. Until then, take care.